Okay, this is the lecture video for MAT 1100, lesson 1.4. And in this particular section, we're going to be talking about simple and compound interest. So we begin by trying to distinguish the difference between these two types of interest. Simple interest, you're basically, the main difference is that you're being paid the same amount by the bank. Is when you bring your money to a bank, the bank will pay you what's called interest. It's almost paying you to be a customer to have your money in their bank so that they can use it for loans and various other things. So with simple interest, if that's what you're promised by the bank in order to keep your money there, they would be using this particular formula. And what this particular formula does is it calculates an amount of interest that is the same every single year because it's based always on the original amount that you invested in your account. So if you use this calculation and it turns out, whatever the answer turns out to be for your interest, you're going to be paid that same amount every single year. Whereas with compound interest, they don't just use your original amount, they use the original amount plus the interest that you previously earned. So every year it's growing. So each time they calculate the interest, you get a larger and larger amount. When it comes to these two types of interest, they will be the same on the first year, but once you get to the second year and the third year and each successive year, this starts to grow more quickly than simple interest. So in this formula, just so you can understand the formula, P stands for principal. And principal is the original amount invested. The original amount that you bring to the bank and put in your account. R, this R that you see in the formula, that's called the rate. And the rate must be used as a decimal. So in section 1.1 of your course, we learned how to convert a percentage because they're going to give it to you as a percentage. Notice that in this first example, they're saying paying a 3% interest rate. That's what that means, this percentage, but you need to convert that to a decimal. So this 3%, before you go using it in this formula, you would have to realize that 3%, let's remember what we did in section 1.1, lesson 1.1 for this course. We asked ourselves, where is the decimal? All the way at the end. If you don't see a decimal, it's all the way at the end. And then you slide it 2 places to the left in order for this to be a decimal. So 3% would be the same as 0.03. And any time that any formula uses any kind of a rate, you are going to convert it to a decimal first and then do your calculation. So let's not forget that. So this rate is used as a decimal. That's what the R stands for. P stands for principal as stated, and T stands for time in years. Okay, now let's attempt to use these formulas. The other formula that you see here, which will be used on the next page, so I'll just mention it now. We're going to do simple interest on this page, and there's another example for simple interest, and then on the second page we will do compound interest as well. That formula states that you are going to use this formula. This formula has a power in it. So you would be doing principal times 1 plus the rate, and that is different than this formula, raised up to a power of time, however much time you're leaving your money in the account. So you're going to need to know where your power key is. And I'll demonstrate where it is on my calculator, and yours will be similar on your TI-30 calculator. So this formula is different than this one, and I want to give you a chance to use both of these formulas. Let's go down into the examples. Okay, in this table right here, and there's one more part to it, part C, which is on the next page, You're going to have an original investment, so this will be your P value of $3,000. You have an interest rate of 3%, so this is your R value. And then the other thing that's in the formula, we're doing this kind of interest right now. And I can tell you, I'm going to be writing this like this. When I go to do the interest, I'm going to use this formula right here. This part of the formula, see, A stands for the total amount that's left in your account. And that includes the interest that you're going to earn plus what you originally invested in the account. You're always going to have the amount you originally invested plus a little bit more, and that little bit more that you're going to have in your account is called the interest, which is just this P times R times T, principal times rate times time. So when I go and do these problems, interest, I'm going to write like this. And when I go to do the total amount, I'm going to write this a little bit different. Total amount will be P times R times T, which is really the interest that I've already calculated right here, plus what you started with. Okay, this is the same formula as what you see up here. Okay, here we go. So in this particular problem, I'm going to go interest. I'm going to follow this formula, principal times rate times time. My principal is $3,000. And by the way, when you see these little stars like that, you know that that means multiplication, but I'll just say it anyway, which can also be written like this. When you put the letters right up against each other, that also indicates multiplication. You could also put dots between them. You could also put parentheses around each one. Those are all ways of indicating multiplication. So you don't have to use a little star like that. This is just a more concise way of writing it. P times R times T. Now I'm going to put parentheses around my numbers. Just another way, again, to indicate multiplication times the rate. The rate as a decimal is 0.03, and we are investing this for 1 year. So that the time that you're putting in right there is 1. Okay, so I just put in principal, rate, time. And then you can go in your calculator and you can multiply them. When you put 3,000 times 0.03 in your calculator, whoops, turn it on, that would help. 3,000 times 0.03, and you get 90. Okay, so as stated, I'm going to, keep saying this to try and help you to understand what the difference is between simple and compound interest. Once you know what you're making on the first year, after 1 year, because they calculate your interest at the end of each year, you're going to make that same amount. It's like a paycheck that you get, but your pay scale never goes up. You're just being paid the same amount every single time. And that's exactly how simple interest is. So after 2 years, you would have double this amount. After 3 years, you would have triple this amount. So you can use this formula for each case that you're doing, or you can just, say, how many years have I had my money invested? If it's 15 years, it's going to be $90 times 15. If you want to use this formula each time, you can also get the answer like that. But you would have to use this formula to understand how much you're making after that first year if you're going to use any kind of shortcuts for the years that come after that. Okay, I'm just going to continue to use this formula so that you will get, better exposure using it. Total amount that you would have in your account after 1 year would be whatever the interest is that you've made, $90. So the bank has paid you $90 for having your money in their bank. Plus, of course, there's the money that you started your account with. That's still there as well. So the total amount in your account is $3,090. Okay, then after 3 years, using this formula, again, you could just go 90 times 3 because you're actually getting 90, 90, 90 each of those 3 years. Or just go ahead and use this formula. So interest after 3 years using the principal times rate times time formula for interest would be 3,000, that's your principal, what you started with. Your rate doesn't change. See, your principal amount never changes in simple interest. Your rate never changes for either kind of interest, but the number of years is going to change as they ask you to go from year to year. Okay, again, as I have commented earlier, once you know what you're getting in the first year, that never changes. You get that same amount every year. So after 3 years, it's going to be 90 times 3, and which is 270, and that's exactly what this is going to come out to be. If you were to put this in your calculator, you'll see it's the same thing as 90 times 3. 3,000 times 0.03 times 3. That's the calculation that we have, and as I said, it's 270. If you were going to take the shortcut and just go 90 times 3, then you have to know what you're making the first year. You have to use this calculation at least once. Okay, so final amount after 3 years would be the $270 in interest that you have earned at the 3-year mark, plus the amount that you originally put in your account. And that would be $3,270. Okay, one more regarding simple interest. This is also part of the table on the previous page. And so we're using the same formulas. They want us to do interest first, which is, I'll keep writing the formulas. You can decide what you think you need to put on your index card where you write your formulas and examples. Most students do put the simple interest formula with an example, as well as the compound interest formula with an answer. With an example, excuse me. Okay, so principal, remember the principal never changes. It was 3,000. That's been invested. The rate never changes. And the amount of time is what's changing. So when you're doing simple interest, this rate never changes. This principal never changes, the rate never changes. But the amount of time does change. Time is how many years you've had your money in the account. When you go to calculate this, remember that on the first year we earned $90? Well, the shortcut without putting it in the formula all over again would just be 90. That's what I earned on the first year. I'm going to continue to earn that every year. You could have just went 90 times 10, which is $90. But you're going to see that this 90 times 10 is $90. You're going to see that this gives you the same amount. So 3,000, just showing you that it does give you that same amount, times 0.03 times 10. And there you go. Or excuse me, what did I say? $90, $900. Excuse me, it's $900. Okay, so there you go, using the simple interest formula. Again, I was trying to point out that once you figure out how much you're making in the first year, that original interest amount never changes, and you get paid that amount at that same amount at the end of each year. So this is after 1 year, and then at 3 years, you're going to get 90 times 3, which we saw right here, 270. And then after 10 years, you're going to get 90 times 10, which is $900. So you could have taken that 90 that you originally got on the first year and multiplied by 10, which is $900, or you can put it right into the formula and also get the same answer. They're also going to want you to give the final amount, just like I did on the previous page, which was after 10 years, $900. Plus that original amount of $3,000 is still in your account. So $3,900. Okay, so 3 examples there of how to use simple interest. That original amount never goes up. It just gets multiplied by the number of years that you keep your money in the account. Whereas compound interest works differently. You don't find the interest first and then the total amount. You do it the opposite way. So when you're going to do compound interest, you find the total amount and then work backwards to get the interest that you've earned on that particular year. So let's take a look at that. The interest formula that you are using for compound interest, this is called compound interest. You don't get the same amount every year, so you can't go at these type of problems the same way. So the formula is final amount is equal to principal times 1 plus the rate raised to a power of time. So you have to know where the power key is. Now on the first year that you've had your money in the account using a compound interest type account, you're going to have the same amount as if you had it in a simple interest account, because you can put your money in either type of account. There's not too many banks that offer compound interest, but there are some. So the type of interest that you're going to get after 1 year, it will always match in a simple and compound interest account. But once you move to year 2, anything after year 1, then your compound interest amount no longer matches what you were getting in the simple interest account. Okay, and so I'm going to show that to you. When I go and do the final amount in the account, you're going to see it's the same amount as if you had it in a simple interest account. But then after that, it doesn't match. If I was to do it for 2 years, it would not match. 3 years is not going to match. Okay, so final amount in your account would be principal. Just follow this formula. The principal is $3,000 times 1 plus the rate. And remember, every time we use a rate in any kind of a formula, we use it as a decimal. So the rate would be 0.03, and we're raising this to a power of how long we are keeping it in there, keeping the money in there, which is 1 year. When you put this in your calculator, because this is a power of 1, you don't need to press the power in. But if it was anything bigger than a 1, you would need to press the power in. So this is just going to be, this is how you can simply put it into the calculator. You don't need to put the power in if it's 1. You're just going to press it in just like this. And when you press this in, notice that you get the same amount that you got when you were doing the simple interest problems. You can put that in your calculator, 3,000 times 1.03, and you get 3,090. And that was the same thing that we got in our simple interest problem. We had $90 after the first year. So it matches on the first year and then never again after that. Okay, now you work backwards to get the interest. Notice that we're doing these problems. You have to do these problems in the opposite order that you did the simple interest problems. With simple interest on the previous page, we did the interest first, then we got the final amount. But here you have to do the final amount, work backwards. So working backwards to get the interest. If the final amount in our account is $3,090 after 1 year, and we know that we started with 3,000, just subtract out what you started with, and that'll tell you what you have earned in just interest excuse me, over the course of 1 year. Okay, now let's try it for 3 years, and then I'll do one extra one below because I know this may be a little harder for you than simple interest. Okay, after 3 years, again, working from total amount backwards to the interest. So total amount after 3 years, just follow the formula. It's principal. That's what that P is. Then it's 1 plus R. Now that's never going to change. The rate's never going to change. So it's 1 plus, if 1 plus R was 1.03, it's going to continue to be 1.03. So you don't have to keep plugging it in over and over again once you already know what 1 plus R is. It's just 1 plus the rate. However, this little power right here, that does change because the T stands for time, the number of years that you've had your money in the account. So that's going to change based on the number of years. We have it in our account for 3 years. You need to definitely put that in your calculator. When this power is anything bigger than a 1, it has to be pressed in the calculator. Whereas when it's a 1, you don't have to press it. You don't have to actually use the power key. But anything bigger than 1, you have to know where the power key is. So let's go ahead and press that in together. Okay, it's 3,000 times, this is times right here, times 1.03. Now we're going to take that 1.03 and raise it up to a power of 3. So this is the power key on a lot of calculators. This is called a little caret key, and it gives you a number in the power position. So you're going to press that. You'll see it on the calculator and then feed in the power. The power is 3 in this problem. And your answer ends up being that your final amount is $3,278.18. $3,278.18. Notice that this amount after 3 years is not the same as what we got for our simple interest answer, which we'll look at on the previous page. Here you have 3,278 and some odd cents. And look what you had after 3 years when you were doing the simple interest problem. You just had a flat 3,270. So when you're doing compound interest problems, as you leave the money in the account longer and longer and longer, what you got for simple interest starts to be further and further away from what you're actually earning in the compound interest account. They get farther and farther apart. Right now at 3 years, they're only about $8 apart. Again, look what you had after 3 years, 3,270. Here after 3 years, you had 3,278 and 18 cents. So they're $8.18 apart. Okay, to know what you got in just in interest after 3 years, it would be just like what I did here. It would be the final amount that we had right here minus the original amount, which is the principal, and that'll give you just the interest. Same thing here. Final amount in your account at this point, at 3 years, is $3,278.18. Subtract out what you originally had in your account, and that turns out to be $278.18. So after 3 years, subtracting out the original amount from what you have in the account at this point shows you that in 3 years you have managed to get $278.18 in interest. After 1 year, you've managed to get $90. Okay, let's do that one more time. Come down below, and we're going to do it for 10 years. Let's see what happens after 10 years. So I'll call this part C. Okay, so after 10 years, okay, we're going to do the final amount first using that formula, P times 1 plus R raised to a power of T. So the principal is the original amount, 3,000. 1 plus the rate is 1.03. And the amount of time is 10. Pressing that in the calculator, that would be 3,000 times 1.03 raised up to a power of 10. That would be $4,031. And if we round this off to dollars and cents, these two digits represent the cents. And that would stop it right there at the second number. So if we're trying to decide how to round that number, it rounds up because of the 9. So 4031.75. So this is the final amount that you would have after 10 years. If you're looking for just the interest, then you have to go what you have in the account total minus the original amount. So just in interest, go ahead and put that in your calculator. 403 1.75 minus the 3,000 you initially put in your account, and that means that after 10 years you have earned $1,031.75. $1,031.75 in interest. Okay, so we looked at simple interest as well as compound interest in this section, demonstrated using 3 different examples for simple interest and 3 examples doing compound interest. There's also an application problem here, which is described below this table, and I'm going to finish with that for this section. So last year, Chris opened an invested account with $8,400. At the end of the year, the amount in the account had decreased by 6.5%. How much is the decrease, and how much money is left in the account at the end of the year? Well, you have to find the decrease first. There were problems like this in section 1.1, I believe, or 1.2. They didn't have anything to do with banking. Now we're talking more about banking type problems, but you can do increase and decrease problems in a manner of different ways. So right now we're talking about investment problems. So the main idea is for you to understand that you have to find the decrease first, and that is what they're asking you for here. So basically you need to know, what is 6.5% of 8,400? What is 6.5% of $8,400? Remember, when you are working with percents and performing calculations using those percents, you must change this to a decimal. That requires, for you to get rid of this percent sign and convert it to a true decimal, you need to move this over 2 spaces. So the equivalent of 6.5% would be 0.065. That's equivalent. Okay, so if you're going to find out what is 6.5% of, remember, this is 6.5% right here, but in decimal form, the way you're supposed to be using it for any kind of calculation. The word of, if you remember us doing this in a previous section, means multiply. And this is what you're finding the 6.5% of the 8,400. Okay, so multiply that out. 0.065 times 8,400. And you get $546. Okay, so that goes here. Okay, then next it asks you, what is the amount at the end of the year-end amount. So he started with, I'll do the work over here, started with 8,400, and the decrease that he has experienced is $546. He has lost $546 in that account. So 8,400 minus 546. So what's left in the account at the end of the year after experiencing a 6.5% decrease is $7,854. Okay, and that concludes section 1.4.